It's chemistry and you are watching Chem Science.
In this video, first we will learn what are strong and weak acids and bases, and then we will also see that what's the difference between concentrated and weak acids and bases, and also then followed by this we will be learning about the reactions of bases, followed by what's the neutralization reaction and how to write the ionic equation of neutralization. So it's really very important to understand the difference between dilute and weak acid, and what's the difference between concentrated and a strong acid, because these are the terms where a general confusion is seen. So you need to know what's the difference between dilute acid and a weak acid, or a dilute base and a weak base. Also, what is concentrated acid or base with strong acid or base. A strong acid or base is completely ionized in a solution form, that is in aqueous form. So let's first see what's a strong acid with an example. For example, if we have a strong acid like HCl, now we know that HCl, hydrochloric acid, is a gas. So when we dissolve that in water, so then what's going to happen is that the hydrochloric acid is going to fully ionize into hydrogen ion and chloride ion. That is called complete ionization. That shows that suppose if we have taken 1 mole of hydrochloric acid, then all the 1 mole of hydrochloric acid molecules are going to ionize into 1 mole of hydrogen ion and 1 mole of chloride ion. So no hydrochloric acid will stay in the molecular form. It will fully ionize into its ions. Similarly, if we take an example of a strong base like sodium hydroxide, again sodium hydroxide when taken in an aqueous form, so we write as an aqueous, that's going to fully ionize into sodium ion and hydroxide ion. And so similar way, suppose if we have taken 2 moles of NaOH molecules in aqueous form, then we will get 2 moles of sodium ions and 2 moles of hydroxide ions. So no molecules will stay in the molecular form. So that's called complete ionization. Now suppose if we have a weak acid or a weak base, then these solutions in aqueous form will be partially ionized in the solution form. Partially ionized in the sense, say suppose we have ethanoic acid, which is a weak acid. Now if we say ethanoic acid in aqueous form, that is dissolved in water, then it's not going to fully ionize all the molecules into its ions. That is, we will get only few ions from the molecular form. So suppose if we have taken 1 mole of ethanoic acid dissolved, then we may not get 1 mole of the ions, that is ethanoate ion and hydrogen ion. We may only get say 0.5 mole or even lesser than this, because ethanoic acid is a very weak acid. So incomplete ionization or partial ionization is what is called a weak acid or a weak base. Another example of a weak base is ammonia. Ammonia is a weak base. When we dissolve that in water, then we get NH4 plus ion and hydroxide ion. Now if we have hydroxide ion, again the same thing applies, that suppose if we have taken 1 mole of ammonia, we will not get 1 mole of ammonium ions and 1 mole of hydroxide ions. That will be lesser than that, because ammonia doesn't ionize fully. It will ionize only partially. So only few molecules will ionize, and that's called a weak base. So that's the difference between a strong acid and a weak acid, a strong base and a weak base. Then what is a concentrated acid or a concentrated base? Now what's the difference between a strong acid and a concentrated acid? Here is the main confusion, that at times it's taken as strong acids are always concentrated, but no. Suppose if we have taken an example of hydrochloric acid, which is a strong acid. Hydrochloric acid can be concentrated also, and it can be dilute also. This says that when a large number of moles of any molecule, any compound is dissolved per unit volume, then it's called concentrated acid. So in hydrochloric acid, if a large number of molecules are dissolved in water, then we get a concentrated acid. And if only few molecules of hydrochloric acid is dissolved in water, then we get a dilute acid. That's the main difference. Similar thing applies to the concentrated base also. So we can say that hydrochloric acid can also be concentrated in dilute in the same way. Even the weak acid, say ethanoic acid, can also be concentrated and dilute depending on how many moles or molecules of the acid we have dissolved. Same thing applies to the base also. So in this case, we can say that the dilute solution has a very small number of moles relative to the solvent. So we can say that in a dilute solution, most part contains the solvent itself, because the dissolved molecules, that is the solute molecules of acid or base, is present in a very small amount, and that makes the solution to dilute. Now let's start with the reactions of bases. Now when the bases reacts with the acids, it forms salt and water. We have already seen few examples when we are having a look at the reactions of acid in our earlier video. Here is the similar reactions. For example, if a base like NaOH react with the acid like hydrochloric acid, is going to form a salt, and we have also seen that what is a salt and how is it formed. So when a metal of a base replaces hydrogen out of the acid, a salt is formed. So if hydrogen is replaced by sodium, then we get sodium chloride, and the remaining part which is replaced out is hydrogen and the hydroxide ion, that makes the water molecule. So this is how a strong acid base reacts to form salt and water. Another reaction, say for example, here we had used sodium hydroxide, which was an alkali, but now if we take a base like magnesium oxide, which is a weak base, and oxide of metal is basic in nature, as we already seen that also in our earlier video. So that is also going to react with the acid. So a basic substance can again react with an acid again to form salt and water. So here now we will get magnesium nitrate as a salt, and again we will have water as the product. Now if we want to balance it, then we need to add 2 here, and so this is how a basic oxide, metal oxide, which is basic in nature, will also react with the acid in the similar way. Next, suppose we have a metal carbonate like calcium carbonate. Similar reaction will occur just like an acid base reaction. Now calcium carbonate will react with the acid, replacing out hydrogen by calcium metal, forming calcium sulfate as a salt. But as we have seen here, it's a carbonate which is basic in nature. So carbonate will, along with the hydrogen and oxygen forming water, it's also going to form carbon dioxide, which is formed out of the carbonate part of the base. So in general, we can say that the bases reacts with the acid to form salt and water, but if a carbonate is present as a base, then another third product of carbon dioxide will also be formed. We had seen many more examples of such type of reactions in the reactions of acids in our earlier video. If you want to go through such examples, you can refer it again to have many more examples of such 3 reactions. Now let's have a look at one more type of reaction which is basic typically for the bases like alkalis, which is a soluble base. Alkalis are a soluble bases. they may react with ammonium salts. Ammonium salts means the salts or the compounds carrying NH4 plus ammonium ion. These are ammonium salts. For example, ammonium chloride, ammonium sulfate. These are the ammonium salts. So the soluble bases like alkalis reacts with the ammonium salts to form salt, ammonia and water, and we can also use this reaction to test the presence of ammonium ion in any compound. So this is also important analytically. So let's have a look at an example here. Say an alkali like NaOH, sodium hydroxide, is reacting with an ammonium salt like ammonium chloride. Then a salt will be formed. So here the salt formed will be NaCl as usual, and ammonia will also be produced because the NH4 plus ion is going to dissociate into ammonia molecules, and the remaining hydrogen and the hydroxide ion is going to form the water. So this is the equation that is analytically very important, because if ammonium chloride or any other compound carrying the ammonia can be tested analytically by reacting it with any alkali like NaOH or KOOH, such a reaction is going to produce ammonia. Now we know that ammonia is a gas. Now when such reaction is carried out by warming these two substances together, ammonia gas produced is going to turn the damp red litmus paper to blue, and when this red litmus paper turns blue, it confirms the formation of ammonia gas, which in turn confirms the presence of ammonium ion in our compound. So this reaction is analytically important. These are the few important chemical reactions of bases, but other than this, there are few more reactions which are important practical in our life. For example, it also helps in controlling the acidity of the soil, controlling soil acidity. Wherever when fertilizers or pesticides are used in soil, that makes the soil acidic. Now it is very important to control the acidity of the soil for the proper growth of crops. So that's the reason that the soil is neutralized by adding some bases like calcium compounds of say calcium carbonate or calcium oxide. These are added to the soil to control the acidity. One more important use, which is used very widely practically, is that to control the acid of stomach. At times it happens that there is an excess acid secretion in the stomach, and that affects the digestion of our body. So it's important to control the acidity, and then in that case also the medical treatment we intake is a base which neutralizes the extra acid in our stomach. So that's another important practical use of a base reaction here. Now let's see what's a neutralization reaction. When acids react with the bases to form salt, we call such reactions as neutralization, because the effect of acid is neutralized by the reaction of a base. So the best example, which is very commonly seen every time, is the hydrochloric acid reacting with an NaOH to form the salt and water. So here, as the acid property of hydrochloric acid is neutralized or compensated by a base, then we call it as a neutralization reaction. But other than this, it's very important to know the ionic equation of the neutralization reaction. So here let's understand that hydrochloric acid is always taken in the aqueous form, and sodium hydroxide, being a solid, is also dissolved in water to undergo a neutralization reaction. So NaCl also produced in aqueous form and the water produces obviously in liquid form. Now if we want to write the ionic equation of this, we need to understand that the substances which are produced in solid, liquid or gaseous form cannot be written in the ionized form. So what is going to ionize is the hydrochloric acid will be ionized into its respective ions. Also, sodium hydroxide will also be ionized into its respective ions. Now, we can write NaCl also in the same form, but water cannot be ionized further. So, water has to be written in the similar way. In the same form as H2O. Now, here on both sides of the reaction, we can see that sodium ion is same, so we can cancel it because it's going to have no reaction form. Even the chloride ion can be cancelled because the actual reaction is happening between the hydrogen ion, hydroxide ion to form the water. So the ions which are cancelled off, like sodium ion and chloride ion, they are called spectator ion. Now why are these called spectator ions? Because these are the ions which does not participate in the reaction. So after cancelling of the sodium and chloride ion, we are left with hydrogen ion, hydroxide ion forming water molecule. So this is the final ionic equation of neutralization reaction. So whenever we are asked to write the ionic equation of neutralization, this is the only reaction which will be formed after converting all main molecules into ions and then cancelling off the spectator ions which actually doesn't participate in the reaction. And so we will always be left with the hydrogen hydroxide ions forming water molecules.